Hello, everyone, and welcome to our presentation. I am Tuhina Tripathi, and I worked with my team members Rohan Das and Nitin Kumar for this project. We have created a tool called Research Decks that aggregates research papers based on specific topics. Here is the agenda for the presentation. As grad students involved in research, we find it difficult to keep up with the latest research in our areas of interest. So this motivated us to create a research paper aggregator to display all the latest papers at one place. The current version of our tool supports papers posted to archive, but this can be easily extended to include other data sources as well. Users interact with the tool through a Slack bot in which they can enter and update their areas of interest and send search queries to display the latest papers. Here are the implementation details of the tool. We built and hosted our services on Google Cloud Platform. We used Google Cloud Functions for our backend, Data Store for storage, PubSub for message queuing, and Cloud Scheduler for job scheduling. The tool was deployed using Goblet. With this, I pass it on to Rohan to walk us through the architecture.
All right, so talking about the architecture of the application, the user interacts with our tool through Slack using slash commands. We'll take a look at slash commands a little later, but for now, it's enough to know that each slash command invokes a RESTful webhook that is exposed by the application. All such API calls are handled by the API handler service that we see here. There are primarily two kinds of user requests, a user preference operation or a search operation. The API handler handles these requests and queues a job in the appropriate PubSub queue, so either the user's job queue or the search job queue, and sends back an acknowledgement of the request received to the user. The PubSub queues then, in turn, will invoke the corresponding service, so either the user service or the results aggregator service, in order to execute the job, which will again be interacting with the users DB and the results DB. Once the job completes, an appropriate response is returned to the user that initiated the request through a callback URL that was received by us in the initial request. Finally, we have the discovery service that integrates with archive to fetch the papers, the latest papers on all of the topics listed in the topics database. This particular service is invoked at regular intervals throughout the day using a cron job scheduler. Next, we'll move on to the demo. So as a user, if I wanted to update the topics for which I want to see papers, all I need to do is use the update preferences slash command. And to this command, we'll pass in a list of topics as arguments. So let's say question answering and supervised learning. And the app should respond back by saying that my preferences were updated. Now, if I wanted to retrieve papers based on all of the preferences that are already saved with the app, I just need to use the search papers command. And this should return a list of papers across all of the topics listed in my preferences. So as you can see, question answering, supervised learning, adversarial machine learning, etc. And then if we dive into each of the search results, we see that the name of the paper has been listed here, and then each paper has a clickable URL to the archive page for that paper. Next, if I wanted to just search for papers in a specific area, again, we use the search papers command, and this time we'll pass to it, again, a comma-separated list of topics, but for now, let's just say we want to see papers relevant to question answering. And this time we get a list of papers that are all related to question answering. With this, I would like to hand it over to Nitin to talk about how we debugged our application.
For the development and the deployment, we used Goblet, which is a framework for writing serverless APIs for GCP using Python. It provides support for local deployment, which allowed us to debug using VS Code. We appropriately bubbled up the errors along with error messages and stack trace such that they can be viewed through Google Cloud logging interface. It ensured efficient debugging during the development as well as post-deployment. We also automated component testing locally and then used manual testing for the integration due to lack of control over Slack-based UI. We face the challenge of scaling up the data aggregation for topics since the APIs to be called are external and rate limiting, and the topics will increase as the user base grows. So we used fan-out design principle to scale the fetching of the data from the APIs. Now, cloud functions are invoked independently for the topics, helping us scale the system for aggregating the data. PubSub is used to handle the peak load as it can scale automatically as the number of requests are increased. We have also added retry mechanism with exponential backoff in Cloud Function to handle transient failures. That's it from our side. Thank you.